Hello students, today in this module we'll continue our discussion on the chapter Structure of Atom. So far in this chapter we have discussed about the discovery of subatomic particles and different atomic models proposed by eminent scientists, and also we have discussed about the distribution of electron in different cell. For example, we had discussed that carbon containing 6 electron, it is distributed in two cells, that is in the K cell 2 electron and in the L cell the 4 electrons. Here for carbon the L cell is the outermost cell. Similarly, if you take another example, in case of sodium 11 electrons are there and they are distributed as such in the K cell 2 electron, in the L cell 8 electron and in the M cell 1 electron. So for the case of sodium, the outermost cell is your M containing 1 electron. Now, why am I emphasizing on the outermost orbital? For example, in case of carbon, I emphasized that outermost cell of carbon is L containing 4 electron, and in case of sodium, the outermost orbital or the outermost cell is your M cell containing 1 electron. I am emphasizing on the outermost orbital or outermost cell because the electrons that are present in the outermost cell of an element or of an atom is called as the valence shell electrons. And it was observed that atoms of those elements containing 8 electrons in their outermost cell are chemically unreactive. They show a very little chemical reactivity. And because of this reason, we call such type of element as noble gases or inert gases. Let's have a look at the electronic configuration and the distribution of electron in such element. For example, if you take the case of neon, there are 10 electrons are there in an atom of neon and the electrons are distributed as in the K cell 2 electron and L cell 8 electron. Here in the outermost cell 8 electrons are there, or we say it has an octet. So this element containing 8 electron in their outermost cell shows very less chemical reactivity. Similarly, we can take another example. In case of argon, there are 18 electrons are there, and how they are distributed? In the K cell 2 electron, in the L cell 8 electron and in the M cell again 8 electron. Here also in the M cell, as it contains 8 electron, we say it has a complete octet, and because of which argon also shows a very less chemical reactivity. So any element having 8 electron or which can achieve 8 electron in their outermost cell will have a stable electronic configuration or will be very much stable in the nature. But there is an exception is also there. For example, in case of your helium, it contains only 2 electrons. In case of helium, the number of cell is only 1, that is the K cell, and it contains 2 electrons. As you know, the maximum capacity of K cell is 2. That's why we say helium is completely filled, and it also shows a very less chemical reactivity, and we call it as noble gas or inert gas. And looking at all this arrangement, like in case of neon, argon, other elements also try to achieve this octet in their outermost cell by combining with other atoms of other element. So now you know the reason why atoms combine or atom reacts to form molecules or compound. That is because by doing so, they can have or they can achieve an octet in their outermost cell. And how do they do so? They achieve this octet by sharing or by gaining or losing electrons. We will take some specific examples in order to understand how they achieve this 8 electronic configuration in their outermost cell. So let's take one example. If you look at the example of sodium, 11 electrons And how they are distributed? The 11 electrons are distributed as such. In the K cell 2 electron, the L cell contains 8 electron, and the M cell contains only 1 electron. Here in this case of sodium, if you observe it very carefully, if we can remove one of the electron from the outermost cell of sodium, that is from M, it can achieve the electronic configuration of 2, 8. That is the configuration of neon. That means sodium can easily donate 1 electron and its valency becomes 1. The number of electron it can lose determines its valency. So, by losing 1 electron, sodium can achieve a stable electronic configuration. Hence, the valency of sodium is 1. And as you know, sodium is a metal, and metal generally have the tendency to lose electron, and they are called as electropositive. And as you know, sodium forms a ion, sodium ion Na plus. That means by losing 1 electron, it can achieve its octet configuration in the outermost cell. Taking another example, magnesium. Magnesium having number of electrons 12 are distributed as 2, 8, 2, and in the outermost cell it contains 2 electrons. Here also if you observe, if we can remove, or magnesium can lose 2 electrons which are present in the outermost cell, that is M cell, magnesium can achieve the electronic configuration of 2, 8. Now, as magnesium is capable of donating or losing 2 electrons, we say the valency of magnesium is 2. Here magnesium is also a metal and it can easily donate 1 electron. Coming to another example, oxygen if you take. Here in case of oxygen, the number of electron is 8. Distribution are 2, 6. In the outermost cell of oxygen, it contains 6 electron. Now there are 2 possibilities. Either oxygen can lose all the electron, all the 6 electron which is present in the outermost cell, and can achieve the configuration of helium, or else it can achieve or receive 2 electron in the outermost cell and can become the electronic configuration of your neon, that is 2, 8. So, here in this case of oxygen, it is easy for oxygen to receive 2 electron or to add 2 more electron in the outermost cell, and that is what we say the combining capacity of oxygen is your 2, because it can receive 2 electron. The valency, we say negative valency, because it receives 2 electron. So, oxygen valency also 2, but it is negative. Unlike your magnesium, valency is 2, but we call it a positive valency because magnesium can lose 2 electron, whereas oxygen can gain 2 electron. Moving on, we will take some more example so that we can clearly understand what is valency. Remember, there is a difference between valence cell electron and valency. For example, if you look at the distribution of oxygen, the outermost cell contains 6 electrons. So, the number of electron which is present in the outermost cell, that will be called as the valence cell electron. But that is not the valency. Valency is always calculated either the number of electrons it can easily donate or easily can lose, or the number of electron it can achieve in order to have octet in its outermost cell. And also another way we can calculate it, if the number of electrons in the outermost cell is more than 4, in that case simply you can subtract that valence cell electron from 8. For example, in case of oxygen, as you saw, 8 minus 6 is 2. So, we can say the valency of oxygen is 2. So, anywhere if you see the outermost cell contains 1 electron, then that will be valency will be 1. If it contains 2 electron, valency will be 2. If it contains 3 electron, valency will be 3. And if it contains 4 electron, the valency will be 4. But if it is more than 4, 5, 6 and 7, In that case, you need to subtract it from 8. 8 minus 6, 2, 8 minus 7, 1, 8 minus 5, 3. Let us take one example, like in case of your chlorine. Chlorine, the number of electron is 17. How they are distributed? 2, 8, 7. The outermost shell of chlorine contains 7 electron. So, the valence shell contains 7 electron. But what is its valency? If chlorine can receive one more electron in its outermost shell, it can have the octet. So, the combining capacity of chlorine is your 1, or it can achieve one more electron in order to have a octet configuration in its outermost shell. So, here for chlorine also we say the valency is 1, negative valency it is 1, and that is why when chlorine forms an ion, that is the chloride ion, it forms Cl minus. Now I hope from all this example you are very much clear about valency. So, let us recall again what is valency. The combining capacity of a particular atom. What is combining capacity? The number of electron it can lose, or it can gain, or it can share in order to have 8 electron in its outermost shell or to fulfill the octet. That will be your valency. Let us look at the definition that is on your screen. The number of electrons gained, lost or shared so as to make the octet of the electrons in the outermost shell gives us directly the combining capacity of the element. An atom of each element has a definite combining capacity, which we call it as valency. The valency of any atom is very important because it determines the chemical reactivity of that atom. So, the number of electrons which is present in an atom will determine its valency, and the number of electron which is present in the outermost shell will determine its valency. Valency is responsible for the chemical nature of an atom. So, the subatomic particles that were discovered help us to understand the chemical nature of an atom or to determine the valency of an atom. Now, moving on, another subatomic particle which was discovered by Goldstein, that is the proton, which is present in the nucleus of an atom. That gives us another phenomena, that is your atomic number, which is denoted by the letter Z. And what is atomic number? It is number of proton of an atom that is present in the nucleus. So, and as you know, number of proton is equal to number of electrons, which makes an atom electrically neutral. We will take some example of different elements where we will determine the atomic number of those elements. So, look at that table. Hydrogen, the symbol is H, its atomic number is 1. What does that mean? That means the number of proton present in the nucleus of hydrogen is 1. So, also the number of electron will be 1 in a neutral atom of hydrogen. Similarly, if you look at the example of helium, atomic number is 2. That means number of proton is 2. Going in the list, down in the list, if you look at oxygen, atomic number is 8. So, we can determine that number of proton present in the nucleus is 8. So on, if you move on to your sodium, atomic number is 11. So, the number of proton is 11. Moving down in that list, if you go to chlorine, atomic number is 17. That means it contains 17 proton in the nucleus. So, the subatomic particle proton, which is positively charged, determines the atomic number of an element or atomic number of an atom. Now, moving on to the next concept, which is associated with the number of proton and neutron together, which is present in the nucleus, called as the mass number. It is the sum of the number of proton and neutron which is present in the nucleus. As you can see the definition, the mass number is defined as the sum of the total number of protons and neutrons present in the nucleus of an atom, and it is denoted by capital A. And if you take the example, you can see the mass number of chlorine is 35. What does that mean? Mass number of chlorine is 35 means the number of proton, as we know, the atomic number is chlorine is 17. So, the number of proton will be 17 and the rest will be the number of neutrons, that is 35 minus 17 will give us the number of neutrons, that is 18. That means we can say in the nucleus of an chlorine atom, it contains 17 proton, that is the atomic number, and the number of neutron is 18. We will take another example so that we can understand the concept of mass number much clearly. The atomic number of sodium is 11. That means number of proton is 11. But the mass number of sodium is 23. What does that mean? Proton is 11, mass number is 23. That means 23 minus 11, that gives the number of neutrons 12. So, we can conclude here that the mass number of sodium is 23 and it contains 11 proton and 12 neutron in the nucleus. So, dear students, I hope it is clear what is atomic number and what is mass number. As we have studied in the Dalton's theory of an atom, he had suggested that atoms of a particular element will have same atomic number and similar chemical properties. But later on, it was discovered that there are atoms of element which is having same atomic number but different mass number. That means the physical properties was different. And what was the reason behind it? As we know, atomic number is determined by the number of protons. So, what it was observed that the atom which belongs to the same element, it contains the same number of proton, but in the nucleus the number of neutron is different, which makes the mass number as different. And we call such type of species atom belonging to the same element having same atomic number but different mass number is called as your isotopes. So, let us look at the definition. That is a number of atoms of some elements have been identified which have the same atomic number but different mass number. Such atoms are called as the isotopes. The chemical properties of isotopes are similar but their physical properties are different. Because of the difference in their mass number, their physical properties will be different. We will take some example of isotope pairs. For example, if you look at the hydrogen element, hydrogen has 3 different isotopes like protium, deuterium and tritium. In all the 3 cases, what you will observe, the number of proton is same, that is 1. But number of neutron is different in the 3 cases. In case of protium, there is no neutron. In case of deuterium, it contains 1 proton, 1 neutron. That is why its mass number is 2. In case of tritium, it contains 1 proton, 2 neutron, for which the mass number becomes 3. So, what do you observe here? The 3 atoms having same atomic number but having different mass number. The chemical properties will be same but the physical properties will be different. Let us take another example of isotope pair, that is your carbon. Carbon 12 and carbon 14. Generally we say carbon 12, carbon 14. When we say carbon 12 and 14, that indicates the mass number of carbon. And as all of you know, the atomic number of carbon is 6. That means it contains 6 proton in its nucleus. But the number of neutron is different. In one case, it is 6. In another case, it is 8. So, as the mass number is different, physical properties will be different, but the chemical properties will be same. So, we can say atoms of same element having similar atomic number but different mass number is called as your isotope. As the mass number is different, so also their atomic mass will be different. So, in that case, for the calculation purpose, in order to have one value for their atomic mass, we take the average atomic weight or average atomic mass. How do we calculate that? We will take one example of an element where it contains some isotopes having different mass number, and the percentage of abundance in the nature will be given. From that, we can calculate the average atomic weight. Let's look at that. As you know, chlorine occurs in the nature in two isotopic form with mass number 35 and mass number 37, and they are available in the ratio of 3:1. So, how to calculate the average atomic mass of chlorine atom based on this data? Nothing. You need to multiply the mass number with respective percentage of abundance and sum it up with the other mass number multiplied by the percentage. As you can see on the slide, 35 multiplied by 75 by 100 plus 37 multiplied by 25 by 100, and when you solve it, the result will be 35.5 U, and we use the average atomic mass of chlorine as 35.5 U. So, this is how we can calculate the average atomic weight or average atomic mass of different element which having your isotopes. I hope it is clear. Now, moving on to the application or what are the uses. Because of this isotopic form, they have found many application in our day-to-day life. For example, uranium has an isotope which is used in the nuclear reactor. An isotope of cobalt is used for the treatment of cancer, and an isotope of iodine is used for the treatment of the disease called as goiter. So, the isotopes also finds usefulness in the day-to-day life. Another aspect of here where the combination of your neutron and proton is that we can refer to again Dalton's atomic theory, that atoms of two different elements will be different. They will have different atomic number and different mass number, but which is not true. It was observed that in case of some element, although their atomic number is different, but their mass number is same. Atomic number is different means definitely the number of proton will be different. Then how come their mass number is same? Let's look at the example. And this type of species, atoms of different elements having same atomic number but different mass number, is called as your isobar. Look at the definition. Atoms of different elements with different atomic numbers which have the same mass number are known as isobar. Taking one example of such isobar pair is your calcium and argon. As you all know, the atomic number of calcium is 20 and the atomic number of your argon is 18. But for both the atom, the mass number is same, that is 40. That means if you subtract 40 minus 20 in case of calcium, it gives that number of neutron is 20. But in case of your argon, 40 minus 18 gives 22 number of neutrons. Because of this neutron, when you sum it up, it comes that mass number as 40. And this type of species are called as your isobar. So, here we come to the end of this topic. Let's recall what we have studied so far. We discussed about the valency and the valence electron and how valency determines the chemical nature of an atom, and about your atomic number, mass number. Mass number is determined by number of proton and neutron present in the nucleus. So, based on all this discussion of today's module, let us discuss some of the example related to it and some of the questionnaires related to it, so that we can assess ourselves how far we all have understood that topic. So, here is one question for all of you. An atom with 3 protons and 4 neutrons will have a valency of dash. Options are 3, 7, 1, 4. So try to solve it. Apply the concept of atomic number. So if you see that atom contains 3 protons, that means it will have 3 electrons also. So the 3 electrons will be distributed as 2, 1. In K cell 2, L cell 1. So the outermost cell will contain 1 electron. As the outermost cell contains 1 electron, so the valency will be also 1. So the answer to this question is the valency of that atom is 1. I hope you understood that question. Let's take another question. The ion of an element has 3 positive charges. Mass number of the atom is 27 and the number of neutron is 14. What is the number of electrons in the ion? Options are given in front of you. Option A 13, option B 10, option C 14, option D 16. So try to first analyze the question, then answer it. The ion of an element has 3 positive charge. That means that particular atom has lost 3 electrons. After losing 3 electrons, it can become 3 positive. Mass number of atom is 27 and number of neutron is 14. So from mass number, if you subtract the number of neutron, then you can find out the number of protons. 27 minus 14, that gives 13 number of proton. So 13 proton means in a neutral atom of that particular element, it will also contain 13 electron. But as we know, now it is given as that ion has 3 positive charge. That means we have removed 3 electrons from that atom. 13 minus 3, answer will be 10. So the number of electrons which is present in that particular ion is your 10. I hope all of you understood. We will take another example from this topic, that is elements with valency 1 are of what? What can you determine about elements which is having valency 1? Whether it is a metal, whether it is a metalloid, whether it is a non-metal or a metal, it can be either a metal or can be a non-metal, or option D, it is always a non-metal. Now if you try to recall, in case of metal like sodium, it has also valency 1, and in case of non-metals like chlorine, their valency is also 1. So if you correlate it, the answer will be, it can either be a metal or it can be a non-metal. So the option C will be the correct answer. Either it can be a metal or it can be a non-metal. Now let's take another example. In a sample of ethyl ethanoate, the formula is in front of you. In a sample of ethyl ethanoate, the 2 oxygen atoms have the same number of electrons but different number of neutrons. Which of the following is the correct reason for it? That means number of electron is same but number of neutron is different. So what can you conclude about that atom? That means we can say, if number of electron is same, means number of proton is also same. Number of proton same, number of neutron is different. Proton same means atomic number same, and when you add the neutrons, mass number will be different. Species having same atomic number but different mass number are called as, the answer is isotope. So the answer to this question will be option C, that is 2 oxygen atoms are isotopes. So dear students, these all questions are related to this topic. You can find several more questions in the NCERT exemplar, also in your NCERT textbook. Read the chapter thoroughly, solve all these related questions to understand the chapter in a better way. Thank you. Have a wonderful day.